Welcome to Fun with Science, Engineering, and Technology. My name is Mr. Ross, and my assistants this morning are David and Bernard. What we're going to do, it's been a long, cold week, and everybody's been in the house, all locked up behind the snowbanks. We're going to play with some balloons. All right. Do you think we can get any science out of these balloons, or are we just going to play? What do you want? Which do you want to do? You want to do some science, engineering, and technology, or you want to do playing with the balloons?
Play.
You want to play? Can we do both?
Yeah.
All right. First of all, what I'm going to do, this is a little air pump for pumping up balloons. Okay. Bernard, you hold that. Don't let the air out now.
Yep.
You got it?
Yep.
Okay. You get the blue one. And I get the red one.
Red, white, and blue.
Red, white, and blue, right? How about that? That's pretty patriotic. Now, all last week, the temperature was down real low, right? Did you watch the weather on?
Yeah.
And what were the one thing they were talking about was what?
The height of the snow?
The height of the snow, and what else?
The
When it was real
wind
cold.
chill. And
The
stuff.
wind chill. All right, so wind chill. What is wind chill? Do you know?
Like, I don't know, like the wind of the wind, how cold the wind is in one blow or something.
Like when the wind's blowing, how cold it feels.
Yeah.
Not how cold it is, because they had to when they do the weather, right? They
Temperature.
give you the temperature, and then they tell you about the wind chill.
Yeah.
Okay. So what I want you to do right now, we're going to do a little demonstration of wind chill with my balloon. Right? And what I want you to do is I want you to take and go and let the air out against your cheek like that. What happens?
I feel cold.
It feels cold.
Yeah.
Did yours feel cold too?
Mm-hmm.
That's wind chill. Now then, why?
Because it's blowing the air.
Because it's blowing the air. That's obvious. It's blowing the air. That's a pretty good answer. But why just because the air is blowing, it feels cool? Why don't you just stand there and feel cool too? Okay, here's the reason, wind chill. Right? And what wind chill really tells us is how cold it feels, right?
Yep.
And what it basically is telling us how fast the heat energy in our bodies are escaping, right? The only ones that's really important to are people and animals is for the wind chill. Right, so what happens is if you're standing here real still like this, right, and let's say you were completely naked, no clothes on, right, we would look pretty stupid, but
Yeah.
you know, and around us, our body is giving off a little heat. So around us, there's like a little layer of heated, warm air around us. Right?
Yep.
Yeah.
All right. So the amount of heat that leaves our body, right, is dependent upon two things: the temperature of our body and the temperature of the air that's surrounding us. Right. If the air surrounding us, right, is real cold, then the heat transfer, the heat leaving your body going into the air is a lot faster. Right.
Yeah.
It cools you down a lot quicker. Right. But if we're standing real still, right, and not having any air moving around us, we warm the air up around us, right? So if I stand here like this, very, very still, I've got a little thin layer of air around me that's warm. So what happens then is the heat doesn't leave my body as fast and go into the air because I add a little bit of air is warm. When the wind blows, guess what happens to that little layer of air?
It got blown away.
It gets blown away, right? So that the air up against my body now
It's
is a
cold.
lot colder, right? And so the heat transfer from my body into the air is going to be a lot faster. So I'm going to cool down a lot quicker. Right?
Yep.
Yep.
The other thing that happens, right, the other thing that plays into the wind chill is the fact that you have a little moisture on your face here, right here. Right? So do I. So does he. Right?
Mm-hmm.
And it's sort of like when you go in the pool in the summertime and you come out and what happens? You get cool, right?
Yeah.
Why?
Because it's washed off.
Because you have this water on you,
Yeah.
right? And the water, you go out in the sun beats down on it, the water evaporates. And when the water evaporates, it takes heat to cause the water to evaporate. right?
Yep.
And so that cools you down. And the same thing in the wintertime, with a little bit of perspiration or a little bit of moisture, right, blowing across your body, the exposed parts of your body, right, is going to cause that water to evaporate and cool you down further. So there's two things that's going to happen, all right? As the wind's blowing, it's going to blow that little layer of warm air that you have around you, allowing the heat to come from your body into the air a lot faster. And then plus the fact that the water, a little bit of water you may have on you, you get, like if you get wet, you go out and play in the snow and you get wet, right? And it starts, and that air is blowing across, it's going to cause it to evaporate and cool you down even further. Right? That's wind chill. And the faster the air goes,
The colder
the
get.
colder you're going to feel. That's wind chill. All right. The other day, Mr. Richards give you a rubber band, right?
Yep.
What did he have you do with that rubber band?
shoot him with it.
Shoot him with it, right. What he asked you to do was to take and this rubber band, stretch it out, and shoot him.
To explain kinetic energy and potential energy.
To explain kinetic energy and potential energy. In other words, when we take and we stretch this rubber band out, elastic band like this, what do we got?
Potential.
It's potential,
'Cause
right?
it has
And
the
we stretch it out.
potential
Yeah.
to shoot across the room.
So when we let go of it,
Kinetic.
it's kinetic,
Because
right?
it's-
So now then, so kinetic energy, right, is the energy that when it's moving. So let's do this, okay? Come on, let's demonstrate to the camera person over there some kinetic. We got kinetic energy. We're going to let go, and it's going to be.
Kinetic.
We had potential when we had it stretched. When we let go of it,
Kinetic
it's
energy.
kinetic energy. Okay. Where's your balloon, Bernard? Okay. Hold on to that. What's happening when I blow up the balloons?
It
balloon.
expands.
They expand, right?
Yep.
We're stretching them out. Pretty much the same as we did when we stretched out
That rubber band.
the rubber band. So what are we doing when we pump the air in here? We're transferring energy
From the
connect to
from-
potential energy. So this balloon right now has potential energy, right?
Yep.
Yeah.
You sure?
Yeah.
What is energy anyway?
The
It's the capacity to do work, right?
Yeah.
Work is moving things around and so forth. All right, so I've got my balloon. It has all this potential energy stored up in it because what happened is when I blew it up, the outside of this stretched a little bit,
Yeah.
right? And that's where I'm storing some potential energy right now.
Yep.
What happens if I let go of them?
It
The
shoots
balloon
away.
flies away.
You sure?
Yeah.
Let's do it.
Okay.
1, 2, 3. They all flew away, right? They went
Yeah.
somewhere. Did they go in any particular direction?
No.
No, they just went
They all just went all over the place. Why is that?
because it's traveling through air and function.
Because it's traveling through the air? Well, what really is happening back here on the
Yeah.
this
It's
thing is
releasing
flopping
the air.
around, right?
Yep.
And my buddy Sir Isaac Newton, you remember
Yeah.
him?
Yeah.
Okay, he did all these laws of motion and force and so forth. And what he said is, to get this balloon to move, which we did with that kinetic energy, right, is this balloon will move in the direction of the force, right?
Yeah.
So what is happening is we've got some air coming out of the back of it, all right, which is a force, which is going to push the balloon in this direction. But if this thing flops around like this,
It's gonna make
It changes
direction.
the
it's
direction
going
it
to change
moves.
direction, and that's exactly what happens. Is this nozzle we have back here sort of flops around and makes it change direction. Right. So how are we going to get this balloon to fly in a straight line?
You put like a straw on it and
Yeah. To keep hold
to
it
get
straight.
straight.
You think I need to do that?
Oh,
Yeah.
yeah.
Let's try that. So what you're telling me is I can get the force going straight, right? Whatever it is, the balloon or rocket ship or whatever is going to go in a straight line. What about my little car? let's take, and this is my favorite little SUV. All right. Now then, while I'm doing this, what do we know about the mass of this SUV compared to the mass of the balloon?
That's it
Weighs
is much
more.
heavier.
It weighs more, so since we're here on Earth and so forth, and we know that it weighs more, we're going to say it has more mass, right?
Yep.
Yeah.
All right, the more mass something has, it has a lot more mass than this balloon. Right? So the more mass something has, the harder it is to get it to move.
Yep.
Right? Like if you go out and you take your bicycle and you take all the force that you can get and you push your bicycle, you can get it going pretty fast, right?
Yeah.
But if you go down and get a hold of a train and put all the force you can get on the train, it's going to move very fast.
It's not gonna move at all.
It's not going to move at all. Well, you might be able to get it to go a little bit, all right? If the engineer doesn't have the brakes on, you might get it to move. but it's a lot harder to move something with a bit larger mass is what I'm trying to say. Okay, so this balloon, we pump it up and just let go of it. The mass is pretty low, so those balloons took off pretty quick.
Yeah.
Yeah.
Right? So if you weren't watching real carefully, you weren't going to be able to see them move. So now then, what we're going to do, for those who, you guys have done this before, right?
Yeah.
Yeah.
Right, so we're going to pump this balloon up, we're going to hook it here, right? And we're going to have it move my car, but the mass on the car is pretty heavy, so it's not going to move as fast as the balloon. All right, so let's get the rest of our materials here. All right, another little piece of
Yeah, because it doesn't
duct
stay
tape, all right?
Yep.
All right, so David, you're going to have to help me. This is going to become a two-man job here. Okay, what I want you to do is I want you to hold this so the air doesn't get out. All right? I'm going to put the straw up here like this. And we're going to take this piece of tape, just put it all down here. And we're going to wrap the tape around and seal it up as tight as we can so no air escapes. Still got a hold of it? Okay, I got it. Okay. So, this all works right.
Yep.
Yeah.
What's going to happen?
It's gonna hit the ledge.
It's going to go over there and hit the ledge, all right? So let's let it go. And why isn't it moving very fast? We hit the ledge and it
Because
stopped.
of the mass of the little car.
Because of the
Yes.
mass of the little car is a lot heavier, a lot more than the mass of the balloon.
It has to push the mass of that with its own weight to move the thing. So
Mhm. Okay. So, now, what else can we do with a balloon? You have any idea?
Yeah.
Yeah, let's get some more. That one's got a straw on it. We don't want to use that one. Give me a red one. Let's stick with the red, white, and blue thing. What am I doing?
Pumping it
I'm
up.
pumping air. What else am I doing?
Putting potential energy into.
I'm putting some energy into it, and the potential energy, right? Because that thing is here. Bernard, tie that up so the air doesn't get out. Okay, you tie that one. I'll get one of my own. Have we done any science so far?
Yeah.
Yep.
We have? We've done some? Okay.
Can you get it?
No.
I got it.
Well, the reason I give it to you because I always have a problem getting the ends tied on them.
Damn it. I can't. My thumb's too fat.
I got it.
You get it?
Yep. I think. Oh, my finger's stuck.
Damn. You're kidding, right?
These are pretty good balloons.
Yeah.
All right.
Yeah, I can't get it.
Okay, here, take this one. I have to do it all, huh?
Yeah.
If I don't get mine,
You got yours?
I don't think so.
Okay, we gotta go back to red, white, and blue.
I got it.
You got it? You sure?
Yep. There we go.
Okay. What's my balloon doing?
Nothing.
Nothing?
Moving
Oh, it's
around.
moving.
Well, it's moving around a little bit, right? Just because we could also use this to do some static electricity experiments, and the reason it's moving around is because the static electricity on the balloon. It's not doing anything. Are there any forces operating on that balloon?
Yeah.
Gravity.
Gravity? Or why isn't it falling down?
Because it's all up
Hitting this.
the table.
Because we put it on the table, right? And gravity's trying to pull the balloon down. What's the table doing?
Stopping
Putting
it
up,
It's
from hitting,
stopping it.
from hitting the floor.
What is it called?
Okay. My buddy, Sir Isaac, said forces come in pairs. Right? I've got gravity pulling down, a force pulling down on the balloon. The table is exerting an equal force pushing up on it.
Thrust.
So it's just sort of sitting there. It's not doing anything.
Yeah.
Right? So if I take this balloon, hold it up here like this. Right? Hold them still so that it doesn't move around, Bernard. Right? What forces are on the balloon?
Gravity.
Gravity. And what's the other force?
Thrust. Also.
Hmm?
Thrust.
Well, no, there's an upward force by you're
Our
doing,
hand?
but your hand holding it up, right?
Yeah.
If gravity's pulling down on it, your hand's pushing it up.
Yep.
So, is that all the forces that are on this balloon?
No.
Wind. Could.
Well, I mean, we don't have much wind in here. If a wind was
There's-
blowing, we would have a force of the wind blowing on it.
Mm-hmm.
What else? What other forces are associated with this balloon?
Friction. Can you call it friction?
Okay, huh? That's a question, yeah. That could be a good MCAS question. What are the we got gravity pulling down, my hand's holding it up so it sits still, all right?
Yeah. Can you call it friction?
Friction?
Yeah, for moving it around.
Well, if I move it up and down around,
Yeah.
okay, I get some friction on it because of the air. But if I just hold it there, what happened when we blew this up, right? We caused this balloon to
To
expand
wind, yeah.
and
Yeah.
stretch, okay? And so the air on the inside, right, is causing the force to push out. What's this balloon doing?
Holding it in.
It's holding it in, right? So
Push.
I've got a force on the inside because I pumped air into it, pushing out all the way around on the balloon, right?
Yep.
The balloon, the elasticity of the balloon, like the rubber bands we had, is pushing in. There's a force pushing in.
Yep.
Now then, what other force is pushing on that? Same force is pushing on you. What is it? All the time, you hope.
Gravity.
Gravity, right?
Yep.
We've got gravity trying to pull it down. My force in my hand is holding it still. The force on the inside of the air pressure is pushing it out. We've got the elastic force, right?
Air
Is-
pressure.
Aha. Air pressure where? Out here, right?
Yeah.
So what we've got is this balloon, right, there's pressure pushing out. There's an elastic force on the balloon, of the balloon material, pushing in, plus there's air pressure pushing on it. What if I take this balloon and I take it up in the air, and I go up high with it? What's going to happen to it?
It's gonna pop.
Well, eventually it'll pop, but what's going to happen before it pops?
It's gonna keep on expanding.
It's going to expand a little bit, right?
Yeah.
Because what happens is I go up,
There's less air pressure.
that's air pressure, and so what has to happen is the balloon has to
Has to,
compensate for that less air pressure.
with
So this thing is
extend
going to
and
expand a little bit, and so that the elasticity of the balloon is
It's
going to
gonna-
create, force is going to increase, all right?
Yep.
So that it's all balanced up and the balloon doesn't get any bigger. So, what are the forces we got on it? You got any others right now?
No.
That's it?
Yeah.
You sure?
Yeah.
Yeah. I think.
Absolutely certain.
Yeah.
Okay. So now then, if I take this balloon and if I go over it, it drops and it falls. What happens?
It
the
takes a
floor.
little bit time.
It takes a little bit of time, but what happens?
Air rises, so it's.
Gravity, I've removed one of the forces, right?
Yep.
Yeah.
The force of my hand, right? So the balloon is going to start falling because gravity is going to start pulling it down. Okay, we have a little force on it due to what?
I mean, no.
You said it earlier.
Air pressure. I mean, what's it called? The expanding.
Well, as it
inside.
falls, okay, it's falling down through the air, so the
Kinetic
air is
energy.
flowing around over top, and so what's happening?
Kinetic energy. It's in motion.
Like it keeps it in the air because of
You said it before, friction.
yeah.
All right, so as this thing starts to fall down through the air, all right,
Mm-hmm.
there's some friction. All right, what else has happened? What other forces on it?
The weight
if I
of
let go of it, let it fall.
the weight of the balloon, well, the rubber, pulls down the air, but the air is trying to rise up, so it lessens, like slows
when-
down the fall.
There's
When-
friction. Yeah.
When the other day you did a little thing on airplanes, right?
Yep.
What were all the forces on the airplanes?
Thrust.
Wind.
Thrust, okay? In our case, if I let go of this, thrust is being provided by gravity,
Yeah.
pulling it down.
Then gravity. Then friction. Then what else? What else?
You had gravity, friction,
Air pressure.
you
Wind
had
currents.
the thrust, and you also had
The air pressure.
a little lift. All right, so when you were doing the airplanes in the classroom, right?
Yeah.
You did, the airplane had thrust, which in our particular case, the thrust is the gravity pulling it down, right? It also had some lift, right? Which was one of the things you demonstrated was you blew air across the top of the thing, and the
funnel.
the ball came up out of the funnel, right?
Yeah.
Yep.
And what else do you have? So we had gravity, right?
Yeah.
Which in our case, gravity and thrust are the same thing, right? So now then, there was one other one.
A lift. Gravity. Friction.
The other one was called drag.
Drag.
Oh,
Right,
they're
drag.
resistant.
Drag. We got two things that are causing drag here, right? We've got as the balloon starts to fall, it falls through the air. There's a little bit of air friction around the balloon,
Oh, yeah.
right? Causing some drag. Also, as it comes down, if it comes straight down through the air like this, right? The air velocity is coming up over the top, right? And what it does is the air comes over the top. It doesn't come right around the top like this, okay? It comes up and it goes over like this, right? And it goes over like this. So there's a little place right in here where there's a little bit of a vacuum,
And pull
right?
it
Which is trying to
Pull it up.
hold it up, and that's what causes the drag. I don't. You don't ride motorcycles, right?
No.
But if you ride it, what you really can notice, the drag, the same thing, right? You're riding down the road on a motorcycle, and you get behind a big tractor and trailer,
Yeah.
right? And you get up fairly close. What's happening is that tractor and trailer sucks that motorcycle right along.
Because
It's-
It's
Because,
making the wind
because
with it.
as it goes through the air like this, right, the
Yeah.
air coming over the top and around the sides, right, can't come right straight down the back of the tractor and trailer. It goes like this, so there's a
Over
little
the
vacuum.
motorcycle.
Can wear there because it doesn't have no air. It's,
Yeah, it does have.
Really?
So and you get the same effect, right? If you're doing a road race,
Yeah.
right? You're out running, right? And you want to be first?
yeah.
yeah.
No,
No,
you only want to be
second.
first when you cross the finish line.
Because you're gonna be sucked.
Yeah, what you want to do is, if you're running or you're riding a bicycle, whatever you want to do,
Go
But
behind someone.
you want to get behind that guy that's running first, okay?
Yeah.
Because he's expending all the energy to suck you along, right? And so you're back there just loping along, being
Yeah,
nice
but-
and casual until you get to the finish line, and you hope he's tired enough that you can run around him and go across the finish line first. So, and if you look at the car races on the
He stays behind.
yeah,
NASCAR and stuff.
yeah, NASCAR and so forth, there's always a guy that sits back behind the leader,
Yep.
right? And hopes he's got enough power when he gets,
That's
because he's conserving his gasoline and everything. So when he gets close to the finish line, he can just come around him and go on because he's being sucked along by that little vacuum in the back. So back to our balloons. I hold it up like this, and forces come in pairs,
Yep.
right? So gravity's pulling down on it. I got to have another force
Pulling it up.
pushing up, right? The air pressure on the inside is pushing out, right? What's holding it in?
Balloon.
The balloon, the
Inside.
elastic,
Yeah.
the balloon
Yeah.
plus
The
The air pressure.
the air pressure here. I thought I said we have forces come in pairs.
yeah.
Yeah. But that's
Well, that's a pair.
Right.
But we had three, right? We had the
Yeah.
pressure on the inside of the balloon pushing up. We have elastic forces on the
Oh,
balloon
pushing it.
pushing it, plus the air pressure pushing in. Right.
But-
But the air pressure,
And the elastic work as the same thing.
yeah, the air pressure and the elastic are both going in the same direction.
So
So we can add them together and call them one force, right? So now then that's our balloon. What's this balloon made out of?
rubber.
Rubber? What's rubber?
stuff like
So like plastic.
Hmm?
So like
We haven't done any engineering and technology. We've done a lot of Newton stuff, all right?
Yeah.
Yep.
But how would you make one of these?
Get rubber from
You got this little balloon, right? Like this.
Mhm.
How are you gonna make one of these? This is a green one.
a rubber tree or something.
From a rubber tree, right? What do you get from a rubber tree?
Rubber.
Rubber.
Wow.
But what do they call it?
Gum or something. No.
They call it latex. Right? These
Oh,
balloons are made out of latex, right?
And-
Which is the sap from a rubber tree. And what they do down in the tropics, all right, they have these rubber tree plantations, and they go out and they tap the tree
Yep.
and get the latex out, which is about to color your shirt, all right? The same way as in a couple of months now, the people up north are going to do what?
make it into something. Or
The
a
people
balloon.
up north are going to tap the maple trees and get maple
and
syrup,
same-
right?
Yeah.
So and it's the same kind of process, right? So we have latex, which is raw rubber. It's the sap from a rubber tree.
Yep.
Sort of like the sap from the milkweed plants that your milkweed bugs normally feed on, that you're growing up there by
Oh,
the
yeah.
thousands, right? If you take a milkweed plant, you break it open,
It
right?
has
There's a
like
little
milk.
sap coming out of it, and it's a white latex rubbery kind of material. So these are made out of latex. But how do they make them? I mean,
Goes through a process.
it goes through a process. It goes through a manufacturing process. But how do they do that?
They melt
They-
it down.
Then they shape it into a balloon.
How do they make that shape like that?
They take
mold?
bunch of latex and mold it into
Yeah.
like how you make a pot, but without
Yeah. They make a thin mold
mold.
out of it, and they pour in.
They pour it into a mold?
Yeah.
Well, you got an idea. All right. Let me show you how to do this. This could get messy, all right? So I've got some paper. I've got some gloves. So that I'm not going to let you guys get dirty. All right? We don't want to mess up the studio. But if I wanted to make a balloon that was that shape there, what I could do is I could take a form, something like this, right?
Yeah.
That's about the right shape,
Yeah.
right?
Mhm.
And now I need some latex.
Yeah.
Okay.
See that.
Down in the magic bag here,
The latex.
Paint.
I have latex, right?
Oh.
Latex paint. Now, latex is white, so what I had to do to make the paint is they took it and they added some
Some
coloring to it, some chemical.
acrylic.
All right, so what's this?
An opener.
It's an opener.
Yep.
But what is it, really? What
Just-
you studied these things in
A
sixth grade.
level, a simple machine.
It's a simple machine, and which one?
Like,
It's a lever,
Yeah.
right? So if I take my machine that I have here, right, and the little fulcrum is right here, right, and I can pry the lid open.
Left
Okie dokie.
foot. Ooh la la.
Get the lid up. This can of paint is old, right, so it's a little goopy here. Right, let me put on a glove because I'm going to get dirty now. pretend I'm a doctor. Do a little surgery. All right. Now, don't break my mold. All right, so I got some. What do I got done in there? So all if I want to make a balloon of that shape, what I do is I dunk this down in there.
Yeah.
Yep.
Right? But the latex it's pretty thin. It's not real thick in there, right?
Yeah.
So if I dump this down in there, like this,
Wait till it's.
and I pulled it out,
and put it there.
what's going to happen?
It's gonna pour. It's gonna stick to the.
thing,
Ball.
and it's gonna dry out.
It's going to stick and it's going to dry out. But what's happening to it right now?
It's
Some
dripping.
stuff running off, right? It's dripping
The
down
excess is coming off.
there. The excess is coming off of there. So I've got a good start. But if you look at that balloon, that red balloon you have there,
Mhm.
the
Oh, you got the mic there.
do this. How about the thickness of the balloon?
It's kind of like 3 layers or something.
That balloon there. What about its thickness?
It's kind of thicker than that.
But is it even all the way around? Pretty much.
Yeah.
All right. It is pretty much the same thickness all the way around.
Around there.
So if I take this balloon that I'm making here, just like what I have, right, and I let it drain enough, what do you think is going to happen to the thickness of it?
It's gonna be even.
You think it's going to be even?
No.
You
wait,
think
the bottom's gonna be thicker than
the bottom's going to be thicker than the
The-
top part?
Yeah.
Yeah.
All right, so I've got a problem with my manufacturing process that I have here.
Yep.
All right, I messed up because my bottom of my balloon is going to be thicker than the top part of my balloon, and so when I blow it up,
The bottom part's gonna end up popping.
well, the bottom part's going to end up not expanding as much, all right? It's not going to expand evenly, right? Because up here where it's thinner on the top, it's going to expand more. So I'm going to have a funny shaped balloon when I blow it up.
Yeah.
So what they do, right? If we cut your arm and it starts to bleed, what happens?
You have to like put a band-aid on it.
Yeah, but what happens? I mean, if you don't even put a Band-Aid on, what's going to happen normally?
You're
The
gonna
blood's
bleed,
gonna
and then
come
it's
out.
gonna stop.
Yeah, it's going to stop. Why does it stop? Big fancy
Because,
word for that. Coagulate, right?
Coagulate.
As soon as the blood comes out, if your blood is normal, all right, and as soon as it hits the air, it starts to thicken up,
Yeah.
right? And that's what makes that little scab and so forth. Well, what we want to do is we want to coat my little form with some material, some chemicals, right?
Mhm.
That cause that latex to coagulate, right, and form a nice little thin air. And if we got the right amount of materials on the form, right, it causes the thickness to coagulate
And
and be even all the way around, right? And we let the excess drain off, right? And that way we get it even all the way around. Now, tell me about the balloon. What about that piece up there where you
It
pump
rolls
it up?
over the end, so you could pump air into it and blow it
Okay,
out.
but what's that little?
And
I don't have that on this one.
You have
The
to
little
dunk it.
little ridge thing around there.
They take another mold and
They take another mold.
they have a better mold.
While they rolled
You have a better mold. You're insulting my mold, all right? Huh?
What?
Is that what you're doing?
I think.
No. No, they don't have another mold. This is what they do. They have a couple brushes, little tapered brushes that are rotating.
Yeah.
And when this one rotates this way,
It
and one on
rolls.
the other side rotates in the opposite direction. And when this dries up a little bit, this goes down the assembly line, and those brushes come along, and they roll the top part of that thing down.
Oh, so it becomes like.
So it's
So it becomes like that, right?
Yeah.
Just like this piece right here. This is all rolled down, right? Then, right, what we have to do is we have to vulcanize or cure it, right? Because it's going to still stay sort of sticky. One of the problems they used to have with the original rubber, right,
Yeah.
is they made things out of it, but when it got warm,
It
got sticky.
stuck. Yeah.
right? So they had to learn to put some additives in it and put some heat to it and vulcanize it so that it doesn't get sticky. So now then, that's what they have to do next. All right, is it goes through and they get that little lip rolled down, right?
Yep.
So that we got a nice edge on it. Then it goes through an oven. Gets heated to about 200 degrees for about 20 minutes. Right?
Yep.
And that cures it or vulcanizes it so that it comes out like this. How about that? Now, how do I get the letters on it? If I want to print something on it, I'll put my name, my picture, or whatever on the balloon.
You have,
After it's dried up,
You have it
you
screen
stamp.
printed. Like,
Okay, but do I screen print it and it looks like this?
you have to have like a certain machine to do it. Like,
Or some artist does it by.
You're going to sit down and you're going to draw that on every one of them, huh?
Yeah.
we're going to do 500,000 balloons today. I want you to draw the outline on it.
Oh, they have like a mold and it's stamped. or
Okay, there's
something.
two ways. One is a screen print, all right? And what they do is they stretch the balloon out in a special little thing, right? And they screen print on it, right? The other way they do it is they blow the balloon up, right? And they do an offset print, right? They blow the balloon up to about 80% its actual size, right? And then the same type of press, well, special because it's got a print on that round balloon, is they print this paper with,
Yep.
right? Which is an offset press. And they print the labeling on it. And then when they take the balloon and they let all the air out of it again, all right? What happens if you notice the balloons, whenever we blow them up and we let air out of them, are they the same size exactly?
No.
No, you can
It
look at them and you can
shrinks.
tell that they're gonna be a little bit floppy. They're a little bit bigger than what they would normally be. Right, so what they have to do then is they run it back through a dryer and heat them up a little bit, right? And that makes them come back to the same size and shape they were when they come off of this mold,
yep.
right? So, those are, what kind of balloons?
Latex.
There's the latex
Latex.
balloons. Now, one of the things you notice, I've been holding this thing for a long time,
Yeah.
and you guys haven't said anything to me about, you want to lay it down or anything. But look, even though we have it all dripped down here, what about, even with the coagulate stuff on it, right, what about on the bottom?
There's always one dot.
There's always one little dot on the bottom, right?
Yep.
So if you look at the balloon, well, I can make a machine that takes this thing and keeps turning it around and around and around and around, all right?
But
And,
most,
and make sure that that one little dot doesn't stay up there,
yeah, but
all right? But that's going to be pretty expensive. I don't want to waste all my money turning this.
yeah, so baboons just leave them like that, some of them.
Some of them just leave. Now this
Yeah.
is a pretty good balloon because the little dot that you see there isn't very big, right?
Yeah.
Right, it's pretty much even all the time. So whoever manufactured these balloons probably did have a machine that kept turning this, right, to keep the latex even all around it.
Yep.
More engineering and technology stuff. And we need to get a guy to
Do that.
see what happened here. I got a little spot right there.
Yeah,
That's
so
where it's,
you
So
can.
it's rubbed
that's
off.
because we didn't have anything on it to make it coagulate, right? So it's
So when
running
you,
off.
yeah, when you blow, it's just gonna pop.
Yeah, when I blow it, that little spot's gonna pop, right? So, now, if I take, let me put the lid back on this, right? So we don't spill it all over the place. Get this off because it's getting warm. So, now, what happens? Well, this is going to be tough with this balloon. But what I'm going to do, I'm going to do it down on the other end, right?
Untie it.
No, I'm not going to untie it. I'm looking for some of my things. Oh, over here it is. Okay.
I'm afraid of
What's that?
a needle.
And,
What happens if I stick a needle in a balloon?
it
Pressure
pops.
of the air is gonna shoot out of the hole.
All right, this is all stressed around here, all right? So I put a needle in it, it's going to pop
Real loud.
real loud. You
Yep.
sure about that?
What?
I thought you told me it was gonna, and you're all the way over there. I thought you told me it was gonna pop. Huh?
Because it's still covering the hole so the air can escape.
I took it out.
Oh, you didn't pop it like.
Now then, what's happening?
The air slowly releasing.
Well, it probably will eventually come out, but the air, these latex balloons are a little porous, and eventually the air will leak out through them, right? But
Yep.
it's no air leaking out of that. What if I do this? It popped, right?
Yeah.
What was the difference?
Right here and the when it pop-
One is, and the reason I didn't do it up here because that spot didn't look like it was very big, okay? But so if I put it down in here like this, all right? I can run it all the way down through to what's on the inside.
Yep.
All right, it didn't pop. There's no appreciable amount of air
Gotta
leaking
pop
out of
it.
it. But if I do this, what happens?
it pops.
Yeah.
It pops. Why?
Because
You
pressure.
We got another balloon, or do we pop them all? Okay. What it is right here where the material isn't stretched out, and if we had a big
it's,
gob up here, right, it'd be the same thing, right? It's not under so much stress,
It's thicker, right?
right? There's not so much tension on it.
yeah. So this
So-
this part is ours.
So I can take and I can stick the needle in here, all right, where there's no tension on it, and what I'm doing is I'm going down through between the little molecules on the balloon, and it doesn't pop. But out here, where there's a lot of tension, a lot of force on the balloon, if I put the needle in there, what it's going to do is going to release some of that stress, and it's going to cause the balloon to burst. Right?
Gonna pop it.
Oh, you want to pop it?
Yeah.
You want to try to put the needle in up here where it doesn't pop?
Yeah. Let me
Oh,
try.
try
it.
that first. All right.
Away from me.
Yeah.
Well, put it down so you don't get it. If it goes, it doesn't go in your eye.
Oh.
Yeah, I did it.
See? You're magic.
Yeah. Now can I pop? Yeah.
Pop it. No. Now, like I said, these latex balloons are a little porous.
Yep.
If you take and you go to the party store and you get this thing pumped up with helium,
Yeah, it fly.
It's
Right.
gonna rise.
it flies because the helium is much lighter than the air, and there's a thing called buoyant force, and it causes it to fly. But if you put it on a string and you hang it around for a day, what happens to it?
It loses air.
It loses because the helium molecules can get out through the little porous things on it. So what they normally do, if you want one that's going to last a
They
while,
put it in a paper bag.
you do one of these balloons,
Plastic.
which is it's a plastic, okay? Normally these are referred to as Mylar balloons, but they're not. Mylar is a special plastic that was,
Looks
Well-
like nylon.
it's what?
Nylon.
You're right, it's nylon and polyurethane, right? And the reason is because this balloon's made a little differently than those, right? You don't put these on a form and, dip the form down in some
And just
material.
make a paper.
What you do is it's made out of a flat sheet, right? It's printed on like
And
this,
they seal
and then
the
it's
end.
sealed with heat, right?
Yep.
It's all sealed up with heat. And this is not as porous as the latex, so if you take one of these, you put the helium in it, it stays in for a long time, right? And the other little scientific marvel that they have on these balloons, right? Some engineer really worked hard on this. Yeah, so you can take this balloon, all right, and you can pump it up,
Reese.
and we don't have to go through all the problem we had before of tying the end of it.
Yeah.
Why is that?
Because it has something that seals the end, but then when you
Release it. It's like that gluey thing.
All right, it works just like your heart. Right, in your heart, little heart muscles are pumping blood around, all right?
Yep.
And when it pumps blood out in this direction, and the heart muscle expands again, it doesn't want the blood to come back.
Yeah.
Right, so there's a little valve in there, right? That when it pumps in this direction, the valve opens up, lets the blood go through. And when the blood tries to come back,
It's
the valve
blocked.
closes. Yeah, so what they did is they put one of them little heart valves, if you will, down in here, right? So it allows the air to go in. But when the air tries to come back out this inlet, the valve closes and shuts it off and holds the air in. Ooh, some more engineering marvels. All right, so we take our balloon. We have another one. We got one that's not broken. Where's my pump? The same thing with this, right? This has some one-way valves in it. So I take it and I push, air into the balloon, right? It doesn't allow the air to come back, so it's got a one-way valve in it too, my little air pump. Your tire pump for your bicycle, do they have those old tire, you still use those?
The little.
Yep.
Yeah, they have one-way valves in it. Right. So, we play with our balloons. We do any science?
Yeah.
In 6th grade.
Yeah, we, we did some science, all right? First of all, how many forces are on this balloon right now?
3.
5.
All right, there's
5.
gravity pulling down, my hand's pushing up.
And
There's air pressure on the inside pushing out.
And elastic is pushing in.
The elastic's pushing in,
And the
and
air pressure pushing in.
so we got
5.
5, right? We got 5 forces on this, right? So, if I let go of it, it starts to fall.
Real slow.
It's going to go down real slow. We have some friction because it's passing down through the air, right? When it gets on the floor and it stops, why?
Because of the equal force pushing up.
Because of the equal force pushing up against it. And how do I manufacture this?
You make a mold. You have a mold.
I have a mold.
Then
And have
And I dip it down in the latex,
Yeah.
bring it out, and I have some chemicals on this mold, right, that makes the latex right adjacent to the mold coagulate, right, so that it's all an equal.
yeah, can it come out right now?
Hmm?
Can it come out right now?
Can I kick it off there right now?
Yeah.
No, it's still too wet.
Yeah.
Right.
what if we
What do you want me to? You want me to make a balloon and bring it to the class?
Yeah.
What if we turned on the light bulb? Then the
Well,
heat
that
from
one
the
won't
light-
turn on. It's blown out, right? So, and why do we make these? What's this balloon made out of?
Nylon and poly something.
Poly.
Polyurethane, nylon and polyurethane. And why do we make this one versus this one?
This
Because
one.
this one, it doesn't let air out.
It doesn't let the air out. It also is,
It's reusable.
it's reusable. We can reuse it again. The other thing about it is that these latex balloons only can take certain amounts of
Yeah.
Yeah.
coloring, right? If we were to take and try to make this pearl colored, you know, the little pearly kind of a color some of the
Silver.
balloons are, what it does is it weakens the balloon.
So when you
All right, so
blow
if we
it
were to try to make it silvery or something like that, we'd have to put some stuff in it to make it silvery. And what we do is we weaken the balloon, right? So this is a much stronger balloon than this. So we did a lot of playing with balloons.
Yep.
We learned any science?
Yeah.
Yeah.
A little bit?
Little.
Okay, so that's it for today. And go home and share your magic trick. All right?
Yeah.